Hi guys, welcome to another video. In this video, we will see how to store the downloaded coins in a database and show them in the UI. So in the previous video, we've seen how to download them from Coinmarketcap and then how to display them in the UI. So in this video, we'll just cache them and then uh, before showing them on the UI. So it'll be useful when there is no network and there is no if there is no internet, user can still see the coin data which was downloaded when there was internet. Okay, let's jump into the coding. Yeah, so now let's begin with the repo layer. In earlier video we've created the coin. In this video we are going to create other classes which are needed for database. So in this we are going to use a room for database. So to create a database using room, we need to first create an entity which is nothing but a representation of table, and then we need to create a DAO uh, or which is also called as a database access object, where we need to define different queries we need to perform on the DB. So let's begin with coding. So I'm going to create a package called room in this, or DB. Let's make it DB. So we have the coin, so we can use this as a entity. So I'll just mark it as an entity here. Okay, we don't have the dependencies in place. I'll just add dependencies and then we'll continue. Okay guys, now the dependencies are in place. We need to have room dependency as well as the life cycle Gradle dependencies. And let's go back to our coin.kt. So and let's declare it as an entity. Entity is just like a table, and let's give a name to it. Table name, let's call it coin table, and we have name and rate here. Let's have an ID as well, which will be used as a primary key. Let me reformat this line a bit. I'll declare one more variable here, val id. Declare it as a primary key. This is the primary key, the ID. So now the table is in place. Let's have a DAO and call it coin DAO. Okay, and let's modify it to an interface, and let's declare it as a enter. I think, yeah, let's say this should work fine without any other variables. So let's have a first method like insert list of coins. So I'll have it as a function insert coins, which will take list of coins, list of coins. And we need to give the query as well for every method here. Insert, and then we'll have a method to get all the coins. Function get all get all coins, which will return a list of coins. So we can have a list of coins, so or we can have an observable like a flow. So we can return a flow of coins. Will be Kotlin coroutines flow, which will be a list of coins. So the room library automatically generates the code for these methods, so you don't have to write any code here. You just have to declare what kind of operations you want to do on a DB. So this will be a query, so I'll annotate it with a query thing. We need to provide for queries we need to provide the actual query as well. So the actual query would be select star from the table name is coin table. That should work fine. And let's have another method for updating each coin. So the update would be needed to keep the DB and the server in sync. So we'll see how it will be useful later, but as for now, let's declare the method. Update coin, so which will take a single coin, type coin, and then which gets updated. There should be an update annotation as well. Let's see. Let's write. Yeah, we need to import. For some reason, my Android Studio is not automatically importing. It's the reason for confusion. Yeah. So we have an update annotation as well, which can be used to update a specific row of a table. Okay, now we have our methods in place. Let's see. These should be enough for our app now. Let's see. So we have the DAO object ready, interface ready, and now let's have a database class as well. So which would also be a Kotlin class, which I'll call it coin DB, and it should be an abstract class. AB abstract class. Yeah. Here we need to as a parameter, we need to pass the tables that this database operates on. So let's put an annotation first. Yeah, this is it. So we need to pass in the list of entities and then the version as well. So let's pass in the list of entities. So here yeah, entities. List is, we have only one entity here, which is a coin entity. This should be fine, and then we need to provide the version as well. So let's call it version 1. The version, if you are aware of the older way of writing a DB in Android, the version information is needed to handle the upgrades. So whenever there is a app update, you need to update the version as well, so that like you would get the update callback, which is needed to migrate, like if you in case modify your columns in your DB, or you just add or remove some columns, this version information is needed. A function here which coin top, which returns a coin top. Declare it as a abstract function, I think. Abstract function, yeah, so that we don't have to write anything here. Let me create a companion object. I'll create a method called get instance. It would probably need the context. Instance coin DB. So if instance is equal to null, then we just have to create it within the synchronized block. Synchronized, yeah, within the synchronized block, if the instance is null, let's create the actual object here. Instance is equal to, we need to use room dot database builder. We need to pass in the context, and the database class, which would be CoinDB. CoinDB dot class.java, and then let's call the database coin_db. That's it. This should create a database object. Yeah, I forgot to do one more thing here. This should extend room database, or yeah. So that's it. We are done here creating an instance of CoinDB. Now CoinDB is there, DAO is there. Let's add the return type. which would be CoinDB. Okay, we've created the DB now. Once we have the DB, let's use it as part of the dependency injection. So let's open the repo module and let's have a dependency for DB as well. Get coin DB. Let's mark it as provide so that it will be part of the dependency injection graph. Provides which would be coin db dot instance. So to get the instance of CoinDB, we would need the context. So we can get the context in many ways. Let's in this case I'll pass in the context as a parameter to the constructor of repo module. Val ctx context. We need to handle the sync part now. Yeah, let's modify the coin repo code to sync coins from server to our local DB. Now we need a coin DAO object as well to access the database. So I'll pass in that as an argument to the constructor. So let's do it. Private val coin DAO, type coin DAO. So now we have coin API and coin DAO. So let's modify the let's add. Okay, first of all, there is some issue here, so we'll modify this to because we modified the constructor of coin to include a primary key, the ID as the primary key. So let's modify this here as well. So it would be data dot ID. We're not going to use this function most likely. We will use our new method. Anyway, let's write the sync code first. Suspend function. Sync is also a long operation. Let's add suspend operator to it. Sync coins. See here, similar to here, because sync will be called most likely from the main thread. So that's why we need to change the thread. So let's context dispatchers dot anything should be okay. Let's make it to IO. This code is similar, so let's get the body from the coin API. I mean the response, our response. So once we have the response, So instead of plain list, let's make a map, which is needed as, for the sync. It's to I mean, we need map to it's easy to compare the existing coins versus the new coins. So for that we need a map. So if base is not null, I'll call it remote map is equal to a mutable map of int and coin. Mutable map of, okay, let's use this int and coin. Let's add the coins to the remote map now. Data would be a list. Let's call it a map and our map. So we can add by key data.id. So this is how we add anything to the map. So the data.id would be the key, and then the value would be the whole coin itself is equal to, it's same as this one. We'll just copy paste here. So now we've made the map of coins which are downloaded from server, and now let's query the local DB as well. Now we have the Java object. Coin dot get all coins. So we need, okay, we have the flow, so flow dot first, which will return the first would get the it doesn't listen for the flow, it just gets the first list whatever we get from the flow, and then ends the flow there. It'll be a local list, let's call it local coins. So we have the local coins now, so let's iterate through these coins and see if any of them are present as part of the remote map. If they are present in the remote map, then we'll update the local coin and remove it from the remote map, and at the end we can add the remaining coins which are in the remote map to our local DB. So let's iterate through these coins first. L local coins dot for each, I'll call it L coin. Okay, so for each local coin we'll see if it's present in the remote map. So for that, our map of lcoin.id, so if it's present, so we can do that by let, so it would be the remote coin. So assuming that it's present, I mean, yeah, here if it's not null means it's present in the remote. So now let's update the local one. So for that we'll use coin term dot update coin. We'll just update whatever we get here, and then we'll remove it from the map as well. Remove the key would be t.id. Yeah. So now our map dot so whatever the remaining at the end of this comparison, like we've updated whatever are present locally, and then the new ones are in this case like the leftover ones in the remote map. We'll add it to the db using the insert remote map dot values dot to list. We'll change it to list. List. So we'll insert this list dot. So it will be a coin dot insert or list. Yeah, this should be fine. I mean this code takes care of the sync coins is done now. So let's add a method to get the coins once the sync is done. Function listen coins. So which will return a flow list of coins that coin down dot get all coins. So yeah, so this is fine now. I mean we've added method to listen for coins as well. So now the sync is done, the db part is done. Let's modify the UI part to use this. So we'll go to the UI, which is coin list view model. So get coin repo and then coins. So here instead of getting the coins directly, we'll initiate the sync. So we won't be needing this code. I'll just comment it out. Let's keep this one anyway. Repo dot get coins, or instead of first we initiate the sync coins, and then now yeah, that should be okay for this. During the initialization of this view model, we will get it. We'll write a separate method to listen for coins from the UI. So here function get all coins. It so now see, view model persists across the life cycle, so we don't have to handle any life cycle events in the view model. I mean we obviously, I mean if we are killing the activity, we need to stop everything. But for orientation changes and such things, the view model stays as is. Then yeah, so get all coins, which will return a, so we will return something called a live data, which is a life cycle aware component, which we used earlier as well. So we'll do the same thing. So we'll return a live data of list of coins, repo dot, yeah, we will get the repo object here. Repo dot listen coins dot as live data, so which converts the flow into a live data. So now we have the live data of coins. Let's see what how to update the activity. So here mm, live data. So instead of this code, coin list view model dot, so we'll do get all coins dot observe. So we need to pass in the owner, lifecycle owner, and then same update list. So we won't be needing this anymore. uh, so that's it. It should work fine now. Let's see if everything is in place. So we have the sync code ready, and then we are listening here. So we won't need this code anymore, so just remove this, and then we won't be needing this one. Let's remove it, and then I will go back to repo and let's see if everything is in place. So sync, yes, it's being called. Once the sync is done, we calling listen coins, should get updated. Yeah, that should be all. Let's run and see what we get. Now, okay, there's one more thing here, guys. So we modified this constructor of coin repo, and let's go back to the module and see if it has all the dependencies to create the constructor. So we have coin API and we don't have coin DAO. We have just the coin DB. So instead of coin DB, let's modify it to get coin DAO dot, yeah, so this should work fine. And then we need to modify the repo module as well, the way we create the repo. So we'll go to the application class, which is this coin app. This is where we initialize our Dagger. So here, instead of Dagger coin component dot create, we'll pass in the the module. So the module gets created automatically here. So instead of that, we'll pass in the our own module using the new constructor that we've done. So we'll call builder dot, we'll add the repo module here. So here yeah, repo module, and you need to pass in the context. I think this should be fine. Dot build, that's all. So now the repo module has the constructor, and it has a way to create coin API as well as coin DAO, which are injected to coin repo. The coin repo has the sync code, and the once sync is done, it has a method to listen for the changes, and we are listening from the UI. So this should work fine. Let's run it and see. Okay, the build was successful, and then when it's running, there is an error here. There's a exception. Let's go back and see. Yeah, here is the error. It says that the late init property has not been initialized. So let's do one thing. Let's just remove the late init and change it to uh, a nullable type of CoinDB, and initialize it to null. Let's use Elvis operator here to return the non-null instance. So for that, let's create a method called create db, which returns CoinDB, and let's copy this here. Okay, let's pass in the context. After context, yeah, this is fine. So now create db is there. So let's modify this code here in this get instance to use the Elvis operator. So now we made this a singleton, and let's run it. So it got launched, and we see that the values are latest. Let's see if the value changes. Yeah, that got changed. So that's all. So now we successfully storing locally, and then refreshing the UI whenever there is an update. That's all for this video, guys. Thank you for watching. Please don't forget to like and subscribe to my channel.